Hello students, welcome to the online classes. Class is for BSc students, subject Physics, third semester, Mangalore University, 18th session. The chapter is Diffraction. In this session, we will understand resolving power of a grating. Before going to understand the resolving power of a grating, let us understand what is resolving power of an optical instrument. The ability of an optical instrument to resolve the images of two nearby points is known as its resolving power. Now, the resolving power of a grating is defined as the ratio of the wavelength of any spectral line to the smallest difference in wavelength between this line and a neighboring line such that the two lines appear to be just according to Rayleigh's criterion. Resolving power is equal to lambda divided by delta lambda, where delta lambda is smallest difference in wavelength which can be resolved by instrument at wavelength lambda. Now, in order to derive the expression for resolving power of a grating, let us consider the diagram showing the diffraction pattern formed by the grating Mn, of which A is the width of each slit and B is the opaque spacing between any two consecutive slits present in the grating Mn. So now here the diffraction pattern produced by the grating is caught on the screen by using the convex lens. Now the direction of the nth primary maximum for a wavelength lambda is given by A plus B sin theta n is equal to n lambda. All this is the equation 1. Similarly, the direction of the nth primary maximum for a wavelength lambda plus d lambda is given by A plus B sin theta n plus d theta is equal to n into lambda plus d lambda. All this is the equation 2. Now, these two lines appear just resolved if the angle of diffraction theta n plus d theta also corresponds to the direction of first secondary minimum after the nth primary maximum of lambda. This is possible if the extra path difference introduced is lambda divided by n dash, where n dash is the total number of lines on the grating surface. Therefore, we have a plus b sine of theta n plus d theta is equal to n lambda plus lambda divided by n dash. This is the equation 3. Now, by equating the right hand sides of equation 2 and equation 3, we have n into lambda plus d lambda is equal to n lambda plus lambda divided by n dash. This is the equation 4. Now, by multiplying n inside the bracket, then we have n lambda is equal to n into d lambda is equal to n lambda plus lambda divided by n dash. Now n lambda on both sides of the equation will get cancelled. Then we have n into d lambda is equal to lambda divided by n dash. So now the resolving power of grating is given by lambda divided by d lambda. So now if you rearrange this equation, that is by taking this d lambda to the RHS, then we have lambda divided by d lambda is equal to n into n dash. So this is the expression for resolving power of a grating. So now from this expression it is clear that resolving power of a grating is depending upon number of lines present on the grating surface and also it depends upon order of the primary maximum. Further, from this expression, we can conclude that the resolving power of a grating is independent of the grating constant. Now, let us discuss the distinction between grating spectra and prism spectra. Let us point out some of the difference between grating spectra and prism spectra. In case of grating spectra, a number of spectra of different orders can be on the two sides of the central maxima with a grating, whereas in prism spectra, only one spectrum is obtained. In grating spectrum, wavelength of any spectral line can be measured accurately by knowing the grating element A plus B and measuring the diffraction angle. In case of the prism spectra, the angles of deviation are independent of refractive index of the material of the prism, which depends on the wavelength of light. With grating, the diffraction angle for violet end of the spectrum is less than that of the red, but with a prism, the angle of deviation for violet rays of light is more than that for the red rays of light. The dispersive power of a grating is d theta divided by d lambda is constant for a particular order, whereas the dispersive power of a prism is d mu divided by mu minus 1. The resolving power of grating is equal to n into n dash. It is much higher, whereas resolving power of prism is equal to p into d mu divided by d lambda. So these are the some differences between grating spectra and prism spectra. Thank you.